quadratic, and we're being asked to solve it when it equals 0. Find the points where it crosses the x-axis. Now, we've been given a clue here, because it's n plus or minus root n, that it's not going to factorise. So we're going to have to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. And you do have to remember this formula. Now in this question, I think it's just wise to just take a moment to write out what your a, b and c are going to be, because the a is always the x squared coefficient, the number in front of the x squared, so that's the minus 2. B, always the number in front of the x, which is minus 4, and the c is whatever's added on, which in this case is positive a. So now just take your time to put everything into this formula. Minus 4 plus or minus the square root of minus 4 squared minus 4 lots of minus 2 times by 8, all divided by 2 lots of minus 2. Now take your time, put everything in brackets, because especially if you were then using, if this was from the calculator paper, it would just make sure that everything was sorted, and this should help us. So at the front here I've got minus 4, which is positive 4, plus or minus, so minus 4 squared is 16, minus, now what's going on here? Well, I've got 4 times 8, which is 32, double 32 is 64, but there's one negative, so minus, what do I just say, 64. And all of that's divided by minus 4. So we're then just looking to sort of bring this together into the format we're looking for. So I've got 4 plus or minus the square root of 80, because I've got 16 plus 64, all divided by minus 4. Now don't be tempted to try and do anything that's not mathematically correct with this surd. We need to simplify the surd down. So 4 plus or minus. Now it helps when you sort of know where you're going with this question, but if we can write this as 16 times 5 to make 80, okay, we're then going to be able to simplify the surd to 4 plus or minus root 16, which is 4, times by root 5 divided by minus 4. So dividing everything through by minus 4 is going to leave me with minus 1 at the front. The plus or minus is going to sort of stay the same, because I've got plus or minus 4 divided by minus 4, which is still plus or minus 4, sorry, it's still plus or minus 1 root 5. So the answer we're looking for is minus 1 plus or minus root 5. Okay, so going back to the question, we'll just remind ourselves that we got down to minus 1 plus or minus root 5. And we're being asked to sketch this curve. So looking at the curve, we know that it's going to cross the y-axis at 8. So drawing in our axes, we know it's going to cross at 8. Now, minus 1 plus or minus root 5. Well, we know that we're starting at minus 1, and we're either adding on root 5, which is 2 and a bit, so we're going to sort of end up over here, or we're taking away root 5, so we're ending up here. So we know we're going to get this symmetrical curve. Its highest point, its maximum, because it's a minus x squared, is going to be at minus 1, and it crosses at 8. So we do something that looks a bit like that. Okay, and then we'll just repair this, so putting 8 in there. I don't need to write in where my x-axis crosses, but I can do if I want. So minus 1 minus root 5 and minus 1 plus root 5. And it's important to show that the quadratic that you've drawn actually has its maximum in this quadrant here. If you don't show that, you will lose a mark. Okay, so that was 2 marks for sketching it, giving the value of the y-intercept. Okay, on to part B then. Show that the x-coordinates at the point of intersection of the line with the curve is satisfying this equation. So when we're showing intersection, we are trying to solve the simultaneous equations. So in this case, they're both equal to y. So I've got y equals, oh dear, something's changed. Okay, so part B then, we are looking to show the x-coordinates at the points of intersection. So points of intersection is solving simultaneous equation. We've got y equals k lots of x plus 4, and we've got y equals 8 minus 4x minus 2x squared. So they're both equal to y, so we can put them equal to one another. So kx plus 4 equals 8 minus 4x minus 2x squared. Okay, so once we put this equal to each other, we're going to want positive 2x squared. So let's get everything on to the right, to the left-hand side of this equation. So 2x squared plus 4x minus 8 plus, and let's expand that bracket as well, equals 0. So we're looking for, we've got the 2x squared, we want the x terms together next, so 2x squared plus 4x plus kx, and then I've got plus 4k, should I say, sorry, and minus 8 equals 0. Then I'm just looking at these two pairs of terms here and just checking where it's supposed to go, and yet I can see that both of these are going to factorise as asked. So I've got 2x squared plus the x is being factorised out, so I've got k plus 4x, and in this one I'm taking out a common factor of plus 4, leaving me k minus 2 equals 0 for my first mark. Now for part 2, just a quick bit of theory here. If we've got a line and a curve that don't intersect at all, that would be the discriminant of the intersection b squared minus 4ac would have no solutions, would be less than 0. If you've got a line and a curve that intersect twice, that would be the discriminant of those two things were greater than 0. In our case, it's a tangent, so we've got a line and a curve just touching. In that case, I just missed it. Just touching, just make the curve bigger. There we are, just touching each other. So b squared minus 4ac equals 0. Okay, so we're using the discriminant here for part 2. So we wanted to use b squared minus 4ac equals 0 on the equation we've been given. So a is equal to 2, b is the x coefficient, k plus 4, and c is the rest of it, which is 4k minus 8. And whenever we're using discriminant, I always say just expand your brackets quickly before you sub in, just in case there's any funny business. So k plus 4 all squared minus 4 lots of 2, 4k minus 8 equals 0. So what we're looking to do here is to solve for our two values of k. So expanding our first bracket, which is here k plus 4 squared, gives me k squared plus 8k plus 16. Now if you're not happy with that, just take your time to expand that bracket slightly slower. This second one I'm going to take my time with, so I've got minus 8, 4 times 2, 4k minus 8 equals 0. K squared plus 8k plus 16, and 8 times 4 is 32k, and plus 64 equals 0. So tidying this up, I get k squared, that's going to be 8 minus, so minus 24k, and plus 80 equals 0. Now here I've got something which does factorise. In fact, two numbers that multiply to make 80 and add up to minus 24. Now those two numbers are minus 20 and minus 4. If you don't get that quickly, you could always use the quadratic formula, but if you're comfortable and confident factorising, we've got minus 20 and minus 4 equals 0. And if we expanded that, we'd show that was correct. So my two values of k are 4 and are 20. And that is my final answer for that part of the question.